Greetings, coders. Let's talk about algorithmic thinking here for a second. So an algorithm is just a recipe. It works like a recipe, cooking recipe, where we follow instructions, right? Um, cut up pepper, dice onion, etc. Step one, step two, step three, step four. That's what that is. So let's take a look at an example of how we can do algorithmic thinking then. So let's say that we're going to determine if a number is a perfect square. So let's see here real quick. Is a perfect square. If that number n is a perfect square. First let's look at a couple examples. Perfect square actually though, perfect square is like this, right? So 16 is a perfect square because it can be squared 4 times 4. 4 squared can make 16. 5 times 5 equals 25. So 25 is a perfect square because it can be factored into 5 times 5. So there's a square basically, right? A square, 5 by 5, that makes up that, multiplied together makes that 25. That's a perfect square. So how can we do that, solve that on a computer? Let's take a look at 4.4, or 4 times 4. That square of 16 is 16 a perfect square? We know it is, but how can we determine that on the computer? Well, we kind of think about how we did it in our head. Well, we can determine the square root of 16, right? And then we can say square root equals compute square root of 16. And that's going to be equal to 4, right? Now we can take the floor of that. The floor means that to go to the lowest integer, the next lowest integer. So 4, next lowest integer would be 4. 4.3, the next lowest integer would be 4. 4.9999, the next lowest integer would be 4. There's also something called ceiling, which we won't use here, but 4.3 of the ceiling goes up to the next highest integer. So that would be 5. 4.999 would be 5 also. But basically what we're doing is we're losing the decimal. There's another way to look at that. We're just taking the integer part. That's what floor is called. So we can use floor here. We can say the floor equals, let's say the square root floor to be explicit, equals the floor, compute floor, floor of square root. All right, so what do we have? We have, then in this case here, the square root of the square root is 4, so the floor would be 4. So are these two equal? Is the question. Is that equal to that? If square root equals, then we have a square. Or we could say is perfect square equals square root equals square root floor. If those two values, and they do in this case, 4 and 4, so they're equal, so we do have a perfect square for 16. Let's try 18. We know that 18 is not a square. So let's try 18. We're going to use the same algorithm here. I'm going to copy that. Same algorithm. Is 18 a perfect square? First off, let's compute here what the square root of 18 is. Square root of 18 is 4.24. 4.24. All right, so square root is 4.24. Now the floor of that is going to be 4, right? Now the question is, does 4.24 equal 4? They do not equal, so that would be false. So is 18 a perfect square? No, it is not. So our algorithm works for both cases, the true and the false case. So we have a good shot here that we have a good algorithm. Let's generalize our algorithm now to any variable n, right? Let's call the number n. So let's generalize it. Let's go here. Let's go like this. We'll say, is n a perfect square? Compute square root of n. And the square root floor is compute floor root of this. Let's generalize that a little bit. Okay. Now, equals that. Here's our algorithm. So then we would convert that into our coding language. So that is algorithmic thinking, and we will talk to you soon. It's fun, isn't it?